The first section has been obtained by removing the frontal poles of the hemispheres, and thus the white matter, the prefrontal white matter, becomes visible, centrum semiovale. And on this section there is no inside gray matter, only cortical areas that are practically subdivided by grooves into gyri. So the grooves are as follows. We have on the convex surface sulcus frontalis superior, sulcus frontalis inferior, that create gyrus frontalis superior, gyrus frontalis medius, and gyrus frontalis inferior, which continues organically on the inferior surface as gyri orbitales of the frontal lobe, which terminate here in the deep sulcus olfactorius. This sulcus olfactorius will create gyrus rectus right here, and as you can see on this side, we have still kept the tractus olfactorius, which is lodged in sulcus olfactorius. Now, on the medial side, we have only one sulcus that is clearly visible. This is sulcus cinguli, but it's cut twice. So sulcus cinguli, two cuts of it as it goes around corpus callosum's genu. So here we have sulcus cinguli subdividing this surface into gyrus frontalis medialis, twice again, gyrus frontalis medialis, gyrus frontalis medialis, and gyrus and of course between the two singular sulci we have the gyrus cinguli, and inferiorly obviously the sulcus, the gyrus rectus. The posterior surface of the previous section contains the genu of the corpus callosum, which will radiate into the two directions posteriorly, will continue here as truncus corporis callosi, of course more posterior just a bit than this, and rostrum corporis callosi inferiorly and posteriorly. Other than that, the fibers of the corpus callosum will go to their respective destinations towards the cortical areas as radiatio corporis callosi in the white matter of the hemispheres here. In fact, there is nothing else on this section than white matter and the anterior horns, cornu anterius, of the lateral ventricles, ventriculus lateralis, that are bordered by these gray matter masses, caput nuclei caudati, on both sides laterally. On the surface, we have the following grooves and gyri. Just like before, we have sulcus frontalis superior and sulcus frontalis inferior, with gyrus frontalis superior, gyrus frontalis medius, and gyrus frontalis inferior, which is the biggest of all of them. Then these continue into gyri orbitalis, the orbitofrontal cortex of the frontal lobe, which stops here at sulcus olfactorius, which is a deep groove and also holds the tractus olfactorius, which is lodged in sulcus olfactorius. And then medial to that we have the gyrus rectus on both hemispheres. On the medial surface we have sulcus cinguli cut twice superiorly, and another time here inferiorly of corpus callosum. So sulcus cinguli and sulcus cinguli. And also we have sulcus corporis callosi right on top of corpus callosum. The gyri that are created here are gyrus frontalis medialis, gyrus cinguli superiorly, gyrus cinguli inferiorly, but this time this part of gyrus cinguli is called area subcallosa because it is right under the rostrum and genu of corpus callosum. This next section is located slightly more behind, but still through the frontal lobe, as you can tell by the presence of the orbitofrontal cortex at this level. And obviously the biggest change here is the enlargement of the frontal horns of the lateral ventricles, ventriculus lateralis, cornu frontale. These frontal horns are bordered by the following structures. We're going to have truncus corporis callosi with radiatio corporis callosi going all the way to the cortical areas. superiorly and a bit laterally as well. The medial wall will be septum pellucidum, which has you can see here two sheets of tissue. And then laterally we have caput nuclei caudati, part of the corpus striatum, the striatal complex, the gray matter deep beneath the frontal cortex. So caput nuclei caudati is communicating laterally to another gray matter area, which we call putamen, which is part of nucleus lentiformis. This is the most ventral area of the putamen, anterior and ventral area of the putamen. Between the putamen and caput nuclei caudati, we have communicating gray matter bridges, which we call pontes grisae caudato-lenticulares, which are intertwined with the white matter fibers of the capsula interna, crus anterius, the anterior limb of the internal capsule. So these gray bridges eventually suggest the involvement as a single functional unit of these two gray matter nuclei in the structure we call striatum. Then the putamen is bordered laterally by this white matter bundle, capsula externa, followed by a gray matter area, the most anterior and ventral part of claustrum, which is separated from the cortex above it by capsula extrema, another white matter area. I didn't mention the corpus callosum's inferior part, the rostrum corporis callosi, which continues, as you can see, as radiatio corporis callosi inferiorly. Now, surface features are simple again. We have sulcus frontalis superior, sulcus frontalis inferior, gyrus frontalis superior, gyrus frontalis medius, and gyrus frontalis inferior, followed by gyri orbitales of the frontal lobe into the orbitofrontal cortex. The next groove is one of the deepest here. It's sulcus olfactorius. Lodged into it we have the tractus olfactorius, and medial to which we have the gyrus rectus. Now on the medial side we will have sulcus cinguli and sulcus corporis callosi, obviously. Between them we have gyrus frontalis medialis, gyrus cinguli, and on the inferior part, next or medial to rostrum corporis callosi, we will have area subcallosa. This next section is going through the brain right behind the commissura anterior, which is an important landmark, and we will have the following features. Ventriculus lateralis, still cornufrontale of it, will be bordered by truncus corporis callosi, superiorly and a bit laterally. Also the radiatio corporis callosi is going to make up some of the white matter of the hemisphere, obviously here. Then medially we will have the septum pellucidum, and laterally we will have the caput nuclei caudati. What's extra compared to the previous slides or sections is going to be the columns of the fornix, columna fornicis, which diverge at this point, and they will head towards the mammillary bodies of the respective hypothalamus. Also lateral here, under the caput nuclei caudati, we have this small gray area which is called the bed nucleus of stria terminalis, nucleus striae terminalis, right here. The columns of the fornix, as they meet commissura anterior, will create a triangular area, recessus triangularis, of the third ventricle. And thus we reach the third ventricle, which has its anterior wall fractured here though, which is called lamina terminalis, viewed from behind, lamina terminalis here. And as such, we also have the optic pathways, tractus opticus cut here 2 times, chiasma opticum, the meeting point in the midline, and nervus opticus, both of them present here. Between them we have the hypophyseal stalk, as it has been going to the hypophysis. Now, right on top of chiasma opticum, right here we have recessus supraopticus, and another recess of the third ventricle going into the hypophyseal stalk is going to be recessus infundibuli, right here. So recessus triangularis, recessus supraopticus, and right in here, recessus infundibuli. The two sides of the wall of the third ventricle, lateral walls of the third ventricle anteriorly here, is made up practically by the ventral anterior hypothalamus. So this is hypothalamus right here. As we move outwards, we will see a bundle of fibers that belongs to the commissura anterior. This is called pars posterior commissura anterioris. And it practically separates this big gray matter mass, which we call striatum and pallidum together, into a ventral striatopallidal structure, striatum ventrale and pallidum ventrale, and a dorsal striatopallidal structure. This striatum and pallidum ventrale is difficult to separate from each other. They also comprise, like at this point, about nucleus accumbens of septum pellucidum. But of course, this will be much more visible, or is much more visible, on a more anterior section where it is mostly closer to septum pellucidum as well. So this is striatum and pallidum ventrale, excuse me. Now the dorsal striatum and pallidum are subdivided into nucleus caudatus caput and nucleus lentiformis, which is further subdivided into putamen, as you all know, and globus pallidus, separated from putamen by this thin plate we call lamina medullaris lateralis. Globus pallidus, it's more visible on this side, is so much lighter in color than putamen, and that will also be separated into two by lamina medullaris interna into globus pallidus lateralis and globus pallidus medialis. Then the nucleus lentiformis is bordered laterally by capsula externa, which separates it from this gray matter area, which has its greatest extent on this section, called claustrum. Claustrum is big here, as you can see. It thins out superiorly, but it's big towards the temporal lobe. This is claustrum, a gray matter area, and then it's separated from the insular cortex itself through or by capsula extrema. And now we made it to the insular cortex, which practically starts here, sulcus circularis insulae, and also here stops, sulcus circularis insulae, the second cut through it, with gyrus longus insulae present here. In the temporal lobe, we still only have white matter, both of them, but there is a hint of the gray matter that will be the amygdaloid body. So corpus amygdaloidum will appear here later, more posteriorly. As far as the surfaces go, surface features go, it's again straightforward. We have sulcus frontalis superior, sulcus frontalis inferior, gyrus frontalis superior, gyrus frontalis medius, and gyrus frontalis inferior, which eventually creates also the operculum of the insula, operculum frontale. Next is a big fissure, fissura lateralis cerebri of Sylvius, followed by operculum temporale, and then obviously the temporal lobe surface, with most likely gyrus temporalis superior and gyrus temporalis medius somewhere here, and of course the occipitotemporal medial gyrus around here, with the parahippocampal as well on the medial surface side. And medially frontally we will have the sulcus cinguli and sulcus corporis callosi, and also gyrus frontalis medialis and gyrus cinguli. This is the posterior aspect of the previous cut, where we will see the columns of the fornix, columna fornicis, as it will delineate from anterior the interventricular foramen of Monro, foramen interventriculare Monro. This is a communication between the third ventricle and the lateral ventricle here, and through this communication the choroid plexuses of the two ventricles communicate with each other. So this is plexus choroideus ventriculi lateralis, and this passes from the third ventricle into this lateral ventricle. Other than that, we have similar structures like on the previous section: caput nuclei caudati, truncus corporis callosi, septum pellucidum, capsula interna, putamen, globus pallidus lateralis, globus pallidus medialis, lamina medullaris interna or medialis, lamina medullaris lateralis. Also, the lateral wall of the third ventricle is created by the hypothalamus, and here hypothalamus also is the inferior wall of the third ventricle. To the sides, on the base of the brain, tractus opticus, bilateral, and in the temporal lobe we have corpus amygdaloideum, parts of it already showing. This section is through the mammillary bodies of the hypothalamus, corpus mammillare, right here. So this means that the lateral ventricles are already passing into the pars centralis. So this is ventriculus lateralis, pars centralis, and the surrounding structures are as follows. Truncus corporis callosi, septum pellucidum in the middle, and these two are corpus fornicis. To the side we have the corpus nuclei caudati, and inferiorly the thalamus. The thalamus will create the inferior wall of the lateral ventricle and the lateral wall, upper lateral wall of the third ventricle. Between the corpus nuclei caudati and the thalamus there is this groove, sulcus terminalis, which is maybe visible better here, sulcus terminalis, that contains stria terminalis right there and vena thalamostriata next to it. From this groove there is a white plate going towards medial, in the medial direction, which is called lamina affixa. Now if we jump into the third ventricle, we'll see here the plexus choroideus ventriculi terzi, which derives from the tela choroidea ventriculi terzi, which is located here in this fissure, which we call the choroid fissure, fissura choroidea, that's going all the way through the lateral ventricles and creating their plexus choroideus as well. The choroid plexus of the third ventricle is attached to this proeminent part of the thalamus, which we call the stria medullaris thalami, and its acute angle, the tenia thalami, for the attachment of the plexus choroideus. Under the thalamus, the wall of the third ventricle is created by the hypothalamus, obviously, which continues inferiorly in its two mammillary bodies, which create the inferior wall of the third ventricle here, corpus mammillare at this level. Lateral to all these, we still have capsula interna, and even more lateral, we have nucleus lentiformis, made up by putamen, lamina medullaris lateralis, globus pallidus lateralis, lamina medullaris medialis, and globus pallidus medialis. Under it, right at the tip of globus pallidus medialis, we'll see almost incorporated in the brain the tractus opticus, also on the other side, tractus opticus. To the lateral, towards the lateral, the putamen is bordered by the white metal plate we call capsula externa, followed by the gray metal plate claustrum, and capsula extrema all the way here under the insular cortex. If we move on to the temporal lobe here, we'll see that the cut is asymmetrical. Here we have a large area of gray matter, which is corpus amygdaloideum, and a small representation of the hippocampus, while on the other side it's inverse. Corpus amygdaloideum is smaller, while the hippocampus is better represented, with this middle area being the hippocampus proper, and on the top, on the surface of it, we have alveus hippocampi, which is a white matter plate that holds the output of the hippocampus. Now, the surface features are very similar to the previous sections. So here we go. We have sulcus corporis callosi, sulcus cinguli, sulcus frontalis superior, sulcus frontalis inferior, fissura lateralis cerebri with sulcus circularis insulae cut here and also here, so 2 times. Sulcus temporalis superior, sulcus temporalis inferior here, and sulcus collateralis most likely. And the gyri then will be gyrus cinguli, gyrus frontalis medialis, gyrus frontalis superior, gyrus frontalis medius, gyrus frontalis inferior, insula, obviously, and then gyrus temporalis superior, gyrus temporalis medius, and gyrus temporalis inferior. And the remaining area here is most likely gyrus parahippocampalis. Oh, and I forgot sulcus hippocampi, more visible on the other side, sulcus hippocampi right here. This more posterior section is going through the base of the brainstem. So we are going to have the following features: truncus corporis callosi, corpus nuclei caudati, thalamus, and crus fornicis, both of them, will delineate ventriculus lateralis, still the central part, pars centralis. Here, between corpus nuclei caudati and thalamus, we will have a groove, sulcus terminalis, in which we will find stria terminalis and vena thalamostriata, visible better on the other side here, and from which a plate of tissue, lamina affixa, is going to be heading towards the medial direction. The free margin of lamina affixa, called tenia choroidea, will be the place of attachment of the lateral limb of the plexus choroideus of the lateral ventricle. The crus fornicis will also have an acute margin here, which will be called tenia fornicis, obviously, and will attach the medial limb of the plexus choroideus of the lateral ventricle here. Then we move on. The third ventricle is bordered entirely by the thalamus. Laterally to it, we have capsula interna still, and also lateral to that, the nucleus lentiformis with putamen, and a little part of globus pallidus lateralis, most likely here. Then capsula externa is next, with claustrum, the gray metal plate, thin here, and capsula extrema under the insular cortex. Now, if we move on to the brainstem, this is the mesencephalic area of the brainstem. We will have nucleus ruber, both sides, and substantia nigra, obviously visible here, and the white matter of the pedunculus cerebri. So this is pedunculus cerebri, the base of the mesencephalon. And then in the temporal lobe, we will have obviously the cornu temporale of the lateral ventricle, which is filled mostly by the hippocampus. This is the hippocampus, hippocampal formation, that is covered by the white matter plate here, which we call alveus. This alveus gathers up into the fimbria hippocampi, which is visible better on this side, and also right under the fimbria hippocampi here, and most likely here, we will have the gyrus dentatus that is showing or is facing outside towards sulcus hippocampi right here. Also, this part of the lateral ventricle contains choroid plexus, so this is still plexus choroideus ventriculi lateralis. On the superior or in the superior wall of the lateral ventricle, we have several areas of interest. Laterally, completely to the side, right here, we have the cauda and the tail, the cauda nuclei caudati. And in the position where we would expect, most likely here, where we would expect the tractus opticus to be, we will have the gray matter we call corpus geniculatum laterale. And right next to it, this white matter stripe is still stria terminalis. So stria terminalis will appear here in the central part, and another section of stria terminalis will be in the temporal horn of the lateral ventricle, stria terminalis. Now, surface features are a bit different, so let's see. We will have sulcus corporis callosi, sulcus cinguli, most likely here sulcus centralis, fissura lateralis cerebri, sulcus temporalis superior, sulcus temporalis inferior, sulcus occipitotemporalis here, sulcus collateralis here, and sulcus hippocampi here. So we will have gyrus cinguli, gyrus precentralis, gyrus postcentralis, gyrus temporalis superior, gyrus temporalis medius, gyrus temporalis inferior, gyrus occipitotemporalis lateralis and gyrus parahippocampalis most likely here. And of course, gyri insulae with sulcus circularis insulae cut in both sides and gyri insulae right here. On the zoom image, I want to explain the attachment of the plexus choroideus of the lateral ventricle and of the third ventricle here. So in case of the lateral ventricle, we have two attachments. We have here lamina affixa with its free margin, which is called taenia choroidea, attaches the lateral limb of the plexus choroideus, while crus fornicis here will have an acute margin right there, which is called taenia fornicis, and this attaches the medial limb of the plexus choroideus of the lateral ventricle. So thus we have two taeniae attaching this single choroid plexus. In case of the plexus choroideus of the third ventricle, we will have this attachment line, which is taenia thalami, obviously attaching the left and the right plexus choroideus partially, and also we can see that between the crus of the fornix and the two thalami, we have here the tissue that is providing the plexus choroideus. This is called tela choroidea ventriculi terzi, and this tela choroidea will eventually go through the fissure, fissura choroidea. This fissure is created between crus fornicis and the thalamus, fissura choroidea, into the lateral ventricle to provide that with a choroid plexus as well. Also, on top of corpus callosum right here, we have indusium griseum and stria longitudinalis medialis, and somewhere here should be stria longitudinalis lateralis. This section goes through splenium corporis callosi and also includes most of the brainstem. This is the tegmentum of the brainstem that contains here aqueductus cerebri of Sylvius that connects the fourth ventricle down here to the third ventricle between the two diencephali. So splenium corporis callosi makes up most of the walls of the central part of the lateral ventricle that on this section turns nicely into the temporal horns of the lateral ventricle. You can see the continuity here. So the central part is bordered by splenium corporis callosi and its radiating fibers outwards. And then inferiorly, we will have corpus nuclei caudati that continues into the temporal horn as cauda nuclei caudati, right here. Then we will have stria terminalis, which also continues on the temporal horn or in the temporal horn. And then from stria terminalis, we have this plate we call lamina affixa, which with its free margin attaches the external or lateral limb of the plexus choroideus. This free margin is called taenia choroidea. And then medially and inferiorly we have the last component, crus fornicis. It's a flat white band with also a free margin. This is called taenia fornicis and attaches the medial leg or medial attachment of the plexus choroideus, which is nicely seen to pass from the superior part into the temporal horn right here, and it is enlarged, extremely enlarged in this section. This enlarged part is called glomus choroideum. On this side we can even see the continuity between corpus nuclei caudati and cauda nuclei caudati and stria terminalis as it continues all the way down to the temporal horn here. Also, the fimbria of the hippocampus, which is cut here on this side and not cut here on the other side, is seen to be continuous with crus fornicis as it's supposed to be. So this is crus fornicis and fimbria hippocampi right here. In the temporal horn, we will then have the hippocampus, the posterior part of the hippocampal proper, covered by alveus and the gathered up fibers of fimbria. Also, we have the cut surface of the thalamus here, pulvinar thalami, the posterior part, which is not cut on the other side. And under the thalamus, we will have metathalamic components like corpus geniculatum mediale here, connected to colliculus inferior via brachium colliculi inferioris, And a bit more anterior and lateral, obviously, we will have corpus geniculatum laterale connected by brachium colliculi superioris to colliculus superior. In the midline, we have the pineal gland here, and in front of it, we will have the commissura habenularum and commissura posterior, which are not visible on this section. At the surface, we will have the following sulci and gyri: sulcus corporis callosi, sulcus cinguli, sulcus intraparietalis, sulcus lateralis, the posterior part of it, sulcus temporalis superior, sulcus temporalis inferior, sulcus occipitotemporalis, sulcus collateralis, and sulcus hippocampi. The gyri are gyrus cinguli, lobulus parietalis superior, lobulus parietalis inferior, gyrus supramarginalis, gyrus temporalis superior, gyrus temporalis medius, gyrus temporalis inferior, gyrus occipitotemporalis lateralis, and gyrus parahippocampalis here. We are down to the last section, where we don't have any more connection between the two hemispheres, since we are behind splenium corporis callosi, and we are looking from anterior towards posterior into the occipital horns of the lateral ventricles, which have the following features. Up here, the radiation of the corpus callosum creates bulbus cornu occipitalis. Underneath that, we have calca ravis, which is a proeminence provided or given by sulcus calcarinus, as you can see here. And eventually, on the inferior wall, we have the trigonum collaterale, which is created by sulcus collateralis, the deep sulcus collateralis here. Laterally, the ventricle is bordered by the tapetum, and lateral to tapetum, we have radiatio optica. On the surface, we have the following grooves and sulci. We have sulcus intraparietalis, then sulcus temporalis superior, its posterior end, sulcus temporalis inferior. We have sulcus occipitotemporalis right here, sulcus collateralis. So the gyri will be precuneus on the medial surface, lobulus parietalis superior, lobulus parietalis inferior with gyrus angularis, then gyrus temporalis medius, gyrus temporalis inferior, gyrus occipitotemporalis lateralis, and gyrus occipitotemporalis medialis.